Hello everyone, this is Jenitha, Department of Computer Science of Engineering, St.Joseph College of Engineering, OMR Road, Chennai. So, on the series of learning about auto-associative memory, today we are going to see something like Hopfield network. Okay, so Hopfield network, it functions like auto-associative memory. So before that, let's see what is auto-associative memory. So here auto-associative memory, it stores the pattern and also it helps to retrieve the pattern. Even the given input is noisy, or if the input is corrupted, or even if there is any missing input. Based on what it have learned, it predicts the data and it try to give the exact input. So for example, let's see, it has a pattern A equal to 10111. Just imagine this is one pattern and it has another pattern. Okay, so if it receives an input, here see there is a missing input. So now what it does, it predicts by what it has learned, or it predicts the pattern by using the pattern which it already which it has been stored or which it has been already learned. It just predicts with that, and now it retrieves, it cleans up all the noisy pattern and it retrieves the data back. Clear? Suppose if it receives a corrupted input, so if it receives an input like this, okay, now again it goes and checks the pattern which it already has, and based on that it cleans up all the noisy pattern and it tries to retrieve back the exact pattern or the exact output to be connected. So this is one of the architecture of neural network, a basic architecture of neural network. So I have drawn here just to give a comparison between the Hopfield network and the basic neural network. Basically, a neural network has 2 layers or at least 3 layers. Okay, so 2 layers means one is input layer and another one is output layer. Every input layer, every neuron in the input layer will receive the input and it produces the output in the output layer. And this layer is nothing but the hidden layer, and it is connected using a weight. The weight is the connectivity strength, that's the W. So W15 is the weight between the neuron 1 and 5, and example W2 and 6 is the weight between the neuron 2 and 6. Okay, so W2 and 7 is between the weight between the neurons 2 and 7. W3 and 8, it's the weight between the neurons 3 and 8. So this is the connectivity strength. Okay, now let's move on to the architecture of Hopfield network. So Hopfield network is a special case. It is something which is completely different from all other neural network. But why do we say that? See, by seeing this architecture, you will clearly understand why. So here we don't have 2 layers or 3 layers. Here we have only 1 layer. Okay, so and we have 3 neurons, and here the same neurons will act as the input and also it acts as the output. The output of the neuron will behave as the input of same neuron. So here it receives 3 input. See, x1, x2 and x3 are the 3 input values for the neurons 1, 2 and 3, and it produces y1, y2 and y3. And also here weight describes the strength between the 2 neurons. Okay, so now we have seen just the introduction about the Hopfield network. Now let's see how to solve a Hopfield network problem. Step instruction how to solve a Hopfield network. Okay, so the first step is define the pattern. So usually when we solve the Hopfield network problem, we will define bipolar patterns. Binary pattern means the pattern will be like this, either 0 or 1. Okay, the pattern will be like this, either 0 or 1, and if it is a bipolar pattern, then it will be either -1 or 1. Okay, in this case, this is the example. Next, after defining it, we should compute the weight matrix, and this is the formula to compute the weight matrix. Sigma p is equal to 1 to n, okay, xp into xp transpose. So we should find out the transpose of this matrix X. The next step, after computing the weight, we should add the whole weight, so we will get one single matrix. Based on that, we should find we should set the diagonal matrix to 0. Okay. Next, in order to find out the energy of the particular matrix, and this will be the formula. E is equal to sigma n equal to 0 to n half, okay, S is nothing but X, the transpose of particular matrix, okay, xp transpose, the transpose of matrix X, then W, the weight which we have computed already, and X matrix. This is how we should solve the problem. Let's put on this problem. So design a Hopfield network for 4-bit bipolar pattern. So 4 bits, see 1, 2 and 3, 4. 4-bit bipolar pattern. I explained what is the difference between binary pattern and the bipolar pattern. Okay. The training pattern are 3 samples are given. So first sample S1, second sample S2 and third sample S3. And what we should find is, we must find the weight and the energy. So this is based on the algorithm. One thing we should remember is the formula, that's it. So first step, what is the first step? So the first step is to define the bipolar pattern. So let's define the bipolar pattern. So what are the bipolar patterns given? S1 is equal to 1, 1, minus 1, 1. So S2, so the sample 2 is minus 1, minus 1, minus 1 and 1. So sample 3, minus 1, minus 1, minus 1, minus 1. So we have defined the patterns now. S1, S2 and S3. So what is the step 2? Let's compute the weight matrix. Based on the formula. So what is the formula? W is equal to okay, S transpose into S. Okay, so let's do it for the sample 1 first. So when S1 is equal to 1, 1 minus 1, 1. So W is equal to S1 transpose into S1. So which implies W is equal to, we should find out transpose 1, 1 minus 1, 1. It's nothing but the transpose of matrix S into 1, 1 minus 1, 1. Okay. So how do we find the okay, this is the product of both the matrix, okay, transpose and the normal sample. So which implies So 1 into 1, 1, 1 into 1, 1, 1 into minus 1, 1 into 1, 1. Again 1 into 1, 1, 1 into 1, 1, 1 into minus 1 and 1 into 1, 1. So first minus 1 into 1, minus 1, minus 1 into 1, minus 1, minus 1 into minus 1 is 1, minus 1 into 1, minus 1. So the last 1 into 1, 1, 1 into 1, 1, 1 into minus 1, minus 1 and 1 into 1 is 1. So this is W1. Clear? Similarly, we should find for rest of the sample, we should find the weight, we should compute the weight for the sample S2 and S3. Okay. So when S2 is equal to weight matrix for sample 2. Okay. So when what is S2? Minus 1, minus 1, minus 1, 1. Then W2 is equal to S2 transpose into S2, which implies S2 transpose minus 1, minus 1, minus 1, 1 into minus 1, minus 1, minus 1, 1. Okay. So how do we calculate this matrix? So minus 1 into minus 1, 1, minus 1 into minus 1, 1, minus 1 into minus 1, 1, minus 1 into 1 is minus 1, minus 1 into minus 1, 1, minus 1 into minus 1, 1, minus 1 into minus 1, 1 again, minus 1 into 1 is minus 1. Again next row, minus 1 into minus 1 is 1, minus 1 into minus 1 is 1, minus 1 and minus 1 becomes 1 and minus 1 into 1 gives minus 1. So 1 into minus 1, minus 1, 1 into minus 1, minus 1, 1 into minus 1, minus 1 and 1 into 1, 1. Okay. So let's compute the weight for the third sample. So when S3 is equal to minus 1, minus 1, minus 1 and minus 1, so W3 becomes S3 transpose into S3, which implies the transpose of the third sample is minus 1, minus 1, minus 1, minus 1 into minus 1, minus 1, minus 1 and minus 1. Let's find the product of these two sample now, which implies, so that means W3 implies minus 1 into minus 1, 1. So here both the samples have negative values. So when we do the product of both the samples, we get positive number. So 1 minus 1 into minus 1, 1. 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 Okay. So finally we get this answer. Since all the values are similar, we get this matrix. Okay. I guess you understood this first step. First we have defined, then we have found out the weight matrix. So till that the second step is not over. As of now we have we got 3 weight samples. So W1 we have got here. Okay. W2 we have got here. This is W2. And W3 we have got here. Now what should we do? We should sum the weight matrix. So by summing the weight matrix we get W is equal to, final weight is equal to W1 plus W2 plus W3. Okay. So which implies, how do we sum it? So where is W1? W1, W2, W3, right? So 1 plus 1 plus 1. So 3. 1 plus 1 plus 1, 3 again. Minus 1 and plus 1 gets cancelled. Plus 1 and minus 1, this 1 and 1 gets cancelled. So here minus 1. Okay. The next one, 1, 2, 3. So 1, 2, 3 again. So next step, minus 1 and 1 get cancelled. Then here another 1. So minus 1, 1. So minus 1. Okay. So the next row, minus 1 and 1 get cancelled. 1 is remaining. Minus 1 and 1 get cancelled. 1 is remaining. Okay. So minus 1, 1 gets cancelled. 1 is remaining here. And again minus 1, 1. So 1 and minus 1 get cancelled. Minus 1. So the last row, minus 1 and 1 makes, so minus 1. And the next one, minus 1 again 1 makes minus 1. So 1 and minus 1 makes 0. So 1. Last one, 1 and 1 makes 3. Okay. So this is the final weight matrix. Weight matrix is this one. So if we set the diagonal value to 0, so the diagonal elements here is 3. We should set all these 3 to 0. Okay. So that is the next step. Swami. So which implies weight is equal to 0, 3, 1, minus 1, 3, 0, 1, minus 1, 1, 1, 0, 1, finally minus 1, 1, 0. So it is well clear that we have set the diagonal value to 0. So this is how we find out the weight. And the next step, what should we do? We should compute the energy for all these 3 input samples. Okay. How do we compute? So what is the formula? E is equal to, energy is equal to, sigma P is equal to 0 to N. Okay. So S transpose into W into S of P. So this is the formula. So let's take the first input sample. So when S1 is equal to 1, 1, minus 1, minus 1, then energy is equal to, oh, we have missed half here, half into, okay. So energy is equal to half into S transpose, into S matrix into weight into S transpose. Okay. So when, let's compute for the first sample, when S1 is equal to 1, 1, minus 1, minus 1, then energy will be half into S1 into weight into S transpose, S1 transpose. So that will be 1, 1, minus 1, minus 1. Pass. So by calculating E1, energy 1, what we have did, so minus half into S1 into weight into S transpose matrix. So first we have found out the product of weight and S transpose. Okay, then again minus half into S matrix into the product of weight into S transpose. Literally by calculating we get E1 is minus 2. Similarly, we have to calculate energy 2 for the sample S2. So we should take the same sample, okay, S minus half into S into the weight into weight into S transpose. So when we calculate that, we get energy 2 will be minus 6. Similarly, we should find energy 3 for the input sample S3. So we get energy 3 is minus 4. This is how we find the weight and the energy. So before that, let's check out quickly. First we have defined the bipolar matrix. Step 2, we have computed the weight matrix. Okay, after computing the weight matrix for all the sample S1, S2, S3, we have summed all the 3 weight, and finally we get one single matrix. Then after getting one single matrix, we have set the diagonal elements to 0. So after setting the diagonal elements to 0, we have found out the energy for all these 3 input samples, and this is the formula: minus half into S into W, the weight, into S transpose. So we have found 3 energy for all the 3 samples. Hope you understood this problem. So thanks for watching, and if you have any comments, comment below. Thank you.